Okay, I'm going to talk about the basics of this eye model. And to begin with, I'm going to talk about the 6 extrinsic muscles. So, right here is the lateral rectus. The lateral rectus moves the eye laterally, and it is innervated by the abducens, cranial nerve 6. I'm going to jump over to the superior oblique. This is the tendon for the superior oblique, so it'll come up here and then go backwards. Like, the muscle itself will be going back there, but this is the superior oblique. It depresses the eye and turns it laterally, and it is controlled by cranial nerve 4, the trochlear. So I covered the superior oblique and the lateral rectus at first for a reason, because cranial nerve 6, cranial nerve 4. The other 4 extrinsic eye muscles are innervated by cranial nerve 3, the oculomotor. So I'd rather just cover those 4 last and say, hey, all these coming up are cranial nerve 3, the oculomotor. And that includes the medial rectus, which will move the eye medially, the superior rectus, which will elevate the eye and turn it medially. And then I have to flip the eye here to see the inferior rectus right there, where my thumb is next to. The inferior rectus will depress the eye and turn it medially. And then right there is the inferior oblique, which elevates the eye and turns it laterally. So notice how the inferior oblique is elevating the eye, and then up here, the tendon for the superior oblique was depressing the eye. So those are the extrinsic eye muscles, their actions, and the cranial nerves that innervate them. So now we can look at the 3 layers of the eye. The 3 layers of the eye are the fibrous tunic, the vascular tunic, and the inner or neural tunic. And so, inside of those layers, then we'll have cavities that are full of humors, and we will talk about those. But you can see the 2 parts of the fibrous tunic. You have the anterior 1/6, which is transparent, and that is the cornea. And that is a place where we are going to refract the light wave as it enters the eye. We refract light 3 places: at the cornea, and then as it enters the lens, and as it exits the lens. So those 3 places we bend the light wave. We bend it most at the cornea. And if we can have laser surgery and change the angle of the cornea and affect the angle of the light being refracted. So that is part of the fibrous tunic. The other part is the white here, and that is the sclera, and that gives the eyeball its shape and allows a place for attachment of these extrinsic eye muscles. So that is the fibrous tunic. And you can see the optic nerve exiting the eye, and that is made up of axons of these ganglion cells in our retina, but we'll get to that. So as I start to take this apart, here I can see the choroid. So the vascular layer is made up of 3 major parts. You have the choroid, this layer, this right here, and this gives vascular supply to all 3 layers of the eye, because since it's in between the other 2 layers, in between the fibrous tunic and the inner tunic, this blood here is able to serve both of those as well. Plus, it has a pigment, melanin, in it, which is going to absorb light waves. So then you have the ciliary body, which I'll show on the inside of this structure, and then, of course, the iris, which is going to regulate size of the pupil to allow light waves into our eye. So as I take this apart, and it's just kind of hard to do. Oops, there goes part of the cornea, or all of the cornea. So now, sorry that my finger was in the way, we see the lens. And so right there is the lens. And so that's not really what I want to show right now, but I just want to point this out here, that now this pinkish layer in here, this tannish layer, that is going to be the retina, the innermost layer. But the reason I want to show first here is that right there is the ciliary part of the ciliary body. So remember the ciliary body, the three parts of the vascular tunic, the middle layer of the eye, are the choroid, this right here. Then we have, the iris, which is going to regulate pupil size, and then the ciliary body, which is attached to the lens, and it's going to regulate the shape of the lens to regulate how we bend the light and how we focus the image. And then, let's see, also in the ciliary body, it's going to produce something called aqueous humor. And so you can see the lens. We said it's attached to the ciliary body. If I stick this back on here, that's the cornea. From the lens to the cornea, this right here, that space, is called the anterior cavity or the anterior segment. The lens is the dividing point, and that's full of something called aqueous humor. And the aqueous humor will provide nutrients to the cornea. And then behind the lens, like right there's the lens, behind it is the posterior cavity or posterior segment, and it's full of a gel-like material known as vitreous humor, indicated by this big thing here. That's meant to be a gel, and that's going to push up against the lens, push back against the retina, and it's going to hold the retina in place and stabilize the structures. And so the third layer is the retina, and like here you can see the macula lutea with the fovea centralis in it, and that's where we're going to have the high density of cones, and cones are for color vision. So this very thin layer right here, the retina, it's got your rods and cones, the photoreceptors, and then they are going to communicate to bipolar cells, and then bipolar cells will communicate to ganglion cells, and the axons of the ganglion cells exit as the optic nerve. And that's the blind spot of the eye, where you're not going to have photoreceptors because that's where the optic nerve is exiting. And you can see the central artery and central vein entering the eye via by the optic nerve. Let's see. So I think that's probably a pretty good discussion. Keep in mind the main layers of the eye are going to be the fibrous tunic, which is composed of the sclera and the cornea. And then we have the vascular tunic, which is composed of the choroid, has a lot of blood vessels in it, and it also is composed of the ciliary body, the white thing that my finger is on, ciliary body, and that's attached to the lens. And then right there is iris, like where it indents, that's iris. We usually think of the iris as the colored part outside of our eye. Then you can see the pupil. And then the innermost layer is the retina. And the retina actually has two layers. You have the pigmented layer of the retina, which has melanin in it, and it will absorb light rays. It will provide vitamin A to the photoreceptors. It will recycle parts of the photoreceptors. It's an important part of the retina. And then you have the neural retina, and that's going to contain the photoreceptors, the bipolar cells, the ganglion cells. So, what happens here is you're going to see a light wave is going to come, and it's going to be refracted right there by the cornea. It's going to pass through the aqueous humor. It's going to pass through the pupil. It's going to be refracted when it enters the lens. It's going to be refracted when it exits the lens. Then it's going to pass through the vitreous humor in the posterior cavity, and then it's going to pass through these cells, the ganglion cells and the bipolar cells, and it's going to interact with the photoreceptors. And when it does that, it causes the photoreceptors to hyperpolarize. Now the photoreceptors are no longer releasing an inhibitory neurotransmitter known as glutamate. In this instance, glutamate is acting inhibitory. So now you're no longer inhibiting the bipolar cells. Then the bipolar cells can communicate to the ganglion cells, and then the ganglion cells' axons exit as the optic nerve. And so that is a basic discussion of the eye model.